Okay, it is 9 a.m. We have YouTube up. I think we're missing a panelist or two. Okay, it is 9 a.m. We have YouTube up. I think we're missing. Okay, there. I think I found the last person we needed. Morning, everybody. Efficient, are you there?
Good morning.
There we go.
Can you post the YouTube link in pools? I don't have it handy.
Already did.
Oh, awesome. Thank you. Okay. Let's see if I can share my screen here.
Should be able to.
Is this gonna work?
There we go.
Awesome.
Well, before we get started, let me do a little kickoff. There's a whole bunch of people who are on this webinar, and they aren't pool operators, so your questions aren't going to be taken. We're talking about the folks who are actually trying to implement pools. Happy to have you listen. That's fine, but please know that your questions are needing to be focused on actual development of pools. Okay, with that, Efficient, take it away.
Okay, good morning, everybody. Thank you for coming to this first Chia Pools for Pool Operators technical, I guess, webinar. I want to reinforce what Gene just said. This is just for technical folks. The main reason why we're doing this is for everybody else, you need your pool operators to be able to work with our pooling protocol to make everything work. So we want to make sure they get a head start on understanding everything. And today is that first step in getting there. Okay. So our agenda today is just do some quick intros and then give you a current status. And then you'll have a tech overview of how pooling works and an actual demo. Yes, it works. And then update on our release dates. Then a lot of time for technical Q&A, and then one last thing. Okay, here we go. So quick intro. These are the people you're going to see on Keybase in the pools channel who are actively helping make pools happen. Okay, and I just want to make sure you guys had a list of who they are. Obviously, you know, Bram created the protocol, and he also had a hand in designing, actually the main hand designing the pool protocol. And then Gene Hoffman is the product manager for pool. So he kind of decides what goes in or out on a 1.0 version of pools. One more time, 1996, which you've seen him post sometimes in Keybase, is the VP engineering for all of Chia, and his main focus right now is on pools. I'm not sure if he's in the chat today, but what have you. Justin, why don't you introduce yourself briefly?
Hi, yeah, I'm Justin England. I think the list of people who don't know who I am is pretty short, but I'm the director of DevOps here. I run, as it says, the test nets as well as all the other ancillary services that help the blockchain run smoothly.
Next is Mariano, who's Sorgente 711. You want to do intro yourself?
Hey everyone, I'm Mariano. I'm working on consensus, pools, cryptography, and things like that. And I will explain today the pool protocol to all the operators. Thank you.
And then you have a few other folks we're going to list here that they may not actually be in the panelists, but they will be active in the pool channels answering questions. You have Matt Howard, who basically created the singleton for the pool NFT. Adam Kelly, which you've seen him interact a few times already in the pools channel. He does all the integration or a lot of integration for the pooling protocol. And then Seaton, who leads the GUI development. And then for myself, you guys all know who I am, so we're going to keep on going here. Okay, so Mariano, take it away.
Thank you. So, all right, so Chia pools design principles. First, I'm going to explain kind of how we designed the Chia pooling protocol and why we made the decisions that we made. And there are a lot of different conflicting requirements that we have to meet. We started basically by thinking about existing proof of work protocols like Bitcoin and Ethereum and how they do pooling. And one of the really important things about pooling is that it's quite a centralizing factor, right? Like the big pools tend to become bigger, people gravitate towards the same pools. And we don't want a situation where one or two pools control like most of the network. And even if it does get to that point, we don't want it so that those two pools can do anything wrong in the network. This is a really, really important requirement. And yeah, Bram, do you want to say something?
I don't know. He keeps raising his hands. May not know why.
Yeah, okay.
So I'm going to lower his hand back.
Anyways, so with previous proof of work, with a lot of proof of work pooling protocols, the pools actually create the blocks and just give a hash of the block to the farmers or to the miners, and then the miners just hash that. So basically the creation of blocks is tied together with the distribution of rewards. And that means that the pools have full control in that sense. With Chia's pooling protocol, and I'm talking about the third bullet point here, the block creation is totally separated from the pooling protocol. So the pool's responsibility is only to distribute the rewards, right? To collect rewards from all the farmers and distribute the rewards into little pieces to all the farmers. So the pool creation is done by the full node, and the farmer can run their own full node, or they can ask someone else to run it, or they can connect to an external party. But the thing is that block creation is separated from rewards distribution for pooling, and that's a really important requirement. So for the first bullet point here, we really want security for farmers. So the farmer never has to trust the pool. The farmer never uploads their private keys to any pool. They just keep their private keys locally. They create and they sign blocks, and then they submit partials to the pool. So that's a really important requirement. One thing I want to point out here is that when comparing proof of work protocols to proof of space, there's a really important distinction which makes things harder for proof of space. And that is that in proof of work, there's no private key. You're just hashing and you submit your hash. If your hash has a lot of zeros, you win, right? So there's no way to scam the pool in proof of work because you're committed to the pool when you're doing the hashes. In Chia, proofs of space actually have a private key, and you have to create a signature with your proof of space. So in theory, you could win in Chia and then potentially sign something different, right? The proof of space is not technically tied to any pool. So that makes things a little bit harder, and why we had to design a lot of stuff to make it secure. So talking about the second point here, security for the pool. So right now, what you can do with the old plots is you can just change your rewards target, right? And basically, you have your pool private key and your farmer private key, and you just change your rewards target and you send rewards to whoever you want. That's not really secure because the farmer can set it to whatever they want. So whenever they win a block, they could just change it to a different pool. Right, if we had pooling just based on changing rewards target, that would not be secure at all because a farmer can scam the pool. So, okay, so what is another way we can design it apart from how it's working now? So the naive way to do the pool protocol is to encode, instead of encoding the public key in the plot, which is how we do it now, we encode the address of the pool in the plot. And that works pretty well, right? The rewards go straight to that pool, and it's cryptographically tied to that pool because the pool's address is in the plot. But there's a big issue with that approach, and that is that you can't change pools, right? So you make all your plots with a pool address, and you're stuck with that pool forever. So we didn't want that approach because that would lead to centralization. It would lead to bad power dynamics. I guess the pool could force you to do certain things because you're stuck with them, and the pool could go offline, etc. So that's really bad. So we really want to support pool switching. So instead of putting the address of the pool in the plot, we're going to put the address of a smart contract called a singleton that the user controls. And I'll get back to that a little bit later. So Another thing for pool security is that the 1.75, 0.25 rewards. So the 1.75 goes to the pool, and the pool distributes that between all the members, and the 0.25 goes directly to the farmer that won that block. This is very important because it prevents attacks where a pool can attack another pool by farming for them, but never actually claiming the rewards. So this actually adds security, and it also adds some nice rewards if you happen to be lucky enough to be the winner. Okay, some of the other design things. Pool switching, which I talked about, it's very important. You don't have to replot to switch pools. There should be no pool registration, no pool username and password. A user can just change their pool and then change the pool on the blockchain and then start pooling with the new pool. They don't have to go to any website to sign up or anything like that. It's basically non-interactive switching. And then finally, one of the other last requirements we had is configless blockchain backup. This means that a user can have two different computers with the same keys, right? The same 24 words. And they can join a pool on one computer, and the second computer would instantly see all those changes, right? They would be able to also pool on computer B. This means that the user doesn't need to go changing config variables or like editing different settings in both of their computers. If they join a pool on computer A, then as long as they have the same keys, computer B will see everything. So in order to do that, we have to put some data on the blockchain, which I'll talk about later. But yeah, that's the main summary of the design principles. So what's in the plots? On the left, you have the plots that we've made up until today, which have a farmer public key, which earns the 0.25, and a pool public key, which will earn the 1.75. They're both controlled by the farmer so far. And then the new plots, which will release shortly, the farmer public key part is still the same to earn the 0.25. But for number 2, you now have something called the pooled contract address, also known as the pay to singleton address. And this is an address of a singleton kind of contract on the blockchain. And I'll explain how that works in the next slide. But before we move to the next slide, I would just like to say that these two things here, the farmer public key and the pool contract address, they cannot be changed once you made the plot, because those two things are hashed together to generate the plot ID. Plot ID is a hash of those two values. And your plot ID determines the whole plot deterministically. So once you choose those values, you can never change them. And that's why we can't change previous plots as well, because they have those values kind of encoded into the entire plot. You can't change these plots once you create them. Okay, next slide. So now I'll explain a singleton. So what we want for these pools is for the user to control some kind of smart coin, which they can use to kind of keep their current pool. So they can have a smart coin, and then they can say, I want to switch pools. And then the smart coin will encode the data for the new pool. So it's kind of difficult to do this with UTXO blockchains, to have like one address that doesn't change forever, because it has to be in the plots, right? So the way we do this is we have something called a singleton, which is kind of like a one of a kind. It's kind of like an NFT. If you create one on the blockchain, there can only be one forever. So the user creates their singleton using the singleton genesis coin. And the singleton genesis coin is just like a coin. It's any Chia that you have in your wallet. This is why you need Chia to create a singleton, because you need to put something on the blockchain, and you need to have a coin to spend in order to put something on the blockchain. So you have the singleton genesis coin at the top, and then you spend that and you create your singleton. You're kind of like setting up your singleton. And then when you create it, you can specify different information like the address of the pool that you're pooling to, the owner public key, which is the public key of the user that can control that singleton. Only one user can control that singleton. And like things like the pool URL and other important metadata. So all that goes in the blockchain. And every time you want to update that, you would spend your singleton and you create a new singleton, which has the same ID. So you kind of like spend, as opposed to Ethereum where you have one contract with the same address that you can just modify. In Chia, it's kind of like Bitcoin. You have to spend a coin and you have to create a new coin that looks the same as the old one, right? So in singletons, it's not like you have one singleton which changes. You always destroy a singleton and create a new one whenever you change it. And it has like an inner thing called the launcher ID, which always stays the same. Anyways, the user can modify the singleton and change the pool they're assigned to. And there's another smart contract called this paid singleton puzzle on the left here. And so puzzle hash, to remind people, is the same as an address. An address is a pretty way to encode a puzzle hash so that users can read it. So the paid to singleton puzzle hash or puzzle, this is what goes into the plots themselves. This is what the user commits to, and this never changes. This paid to singleton puzzle is what receives the funds, right? Because the plot has an address, and when you farm a block, the 1.75 goes to the address that was specified in that plot. Well, this address is called the paid to singleton puzzle hash. So the 1.75 coins go there, but those coins are not directly going to the user or to the pool. They're kind of stuck in this singleton puzzle, paid to singleton puzzle, and they can only be claimed to the pool. So basically this singleton puzzle can only be spent at the same time as you're spending the singleton itself. So you can't spend the paid to singleton puzzle without spending the singleton. And the singleton has the information that says that these rewards will go to the pool. I don't know if this is making sense to people. If there are any questions like Gene or Rich, if there's any things that I can clarify, please let me know.
Nothing yet.
Okay. So again, to reiterate, the thing on the left, the paid to singleton puzzle can only be spent at the same time as you're spending the singleton. And that generates an output. Due to the rules in the singleton, it has to generate an output that goes to the pool. So the 1.75 will be claimed, and the output will go to the pool. It's important to note that anyone can claim this. Anyone can make this transaction in the blockchain for the claim. This is what we call an absorb. And although anyone can make the transaction, not everyone can receive the funds. The funds have to go to the pool address because that's locked inside of the singleton already. The user committed to that beforehand. So there's no way that anyone can steal it from the pool. It has to go to the pool address. And then when the user wants to switch pools, they would just spend the singleton, specify a new pool address, and there's like a timeout of 30 blocks or whatever the pool wants to set it to for that to be finalized, because it's not secure if you can change it without any timeouts. Okay, so this is all blockchain state. The pool has to keep track of each of the singletons of each of their users, and the pool has to always check whether the user singleton is assigned to that pool, right? Because if the user switches to a different pool, the pool has to be like, okay, I'm not paying out to that user anymore because they switched pools. So the pool is always looking at the blockchain. The pool runs a full node, looks at the blockchain, and inspects all of the singletons in the blockchain for their users, and then sees whenever they're changing to a different pool. Another thing I want to talk about now is the difficulty. So usually there's signage points every 9 seconds, and there's a specific difficulty that farmers have to farm. And the farmer sends to each of their harvesters the signage points, right, with the difficulty. So let's say the difficulty is 1,000. That would give you like a proof every 2 months. You know, if you have a few terabytes of space, maybe it takes 2 months to get a proof. So what we want to lower that time significantly. And the way we do that is we want to have a custom difficulty for each farmer. So the farmer can, when they're farming, instead of sending difficulty 1,000 to the harvester, they're sending a really, really low difficulty, maybe 1 or maybe like much lower than that, right? So that, let's say we want to target a proof every 5 minutes for every user. So the farmer lowers the difficulty significantly, sends that to the harvesters, and now the harvester is going to find a lot more proofs. It's as if they were farming in testnet like 6 months ago or whatever. Like, it's really, really easy difficulty. Even with like 10 plots, you should be able to find a proof every few minutes. So there's an artificially lower difficulty, and then the farmer gets the signage points from the blockchain, sends them to the harvester with a low difficulty, and then instead of sending these proofs back to the blockchain, right, instead of sending the winning proofs to the full node, they send the winning blocks to the pool server. And this is something called a partial. A partial is kind of like it's a proof, it's a full proof of space, but it's not good enough for the blockchain, right? So a partial is just a proof of space that is farmed with a lower difficulty. So when the farmer submits partials, the pool can verify these partials and check them against the blockchain, right? Check them against the signage points and see that the user is actually farming properly. The pool will actually check that 25 seconds have not passed, right? If you're taking 40 seconds to answer your signage points, you're probably never going to win, right? Because your setup is bad. So the pool is also a good way to kind of check that your setup works, because the pool won't reward you. The pool won't acknowledge your proofs if they're late. So the farmer reads the signage points from the blockchain, sends to the harvester, gets the proofs from the harvester, sends them to the pool periodically, and then the pool can adjust the difficulty for that farmer. So if the farmer is submitting like a ton of proofs, like one every second, then the pool can say, okay, I want to increase the difficulty for this guy because he's going really fast, right? He's submitting a lot of proofs. Like maybe he grew a lot in space. So then the pool just responds with the higher difficulty, and then the farmer adjusts his difficulty, and basically he will get less proofs now. So every user is targeted for 300 proofs per day, and that's a completely arbitrary number. The pool can set that in the config. So if you're a pool, you can say you want 10,000 proofs per day or 1 proof per day per user. You can do that. You can do whatever you want there, and that depends on the performance, right? You might want to have better performance, so you want to do less proofs, less partials per day per user, or you might want to do more. Anyways, performance is something that should be worked on. It hasn't been worked on so much in the reference code, and that will depend on each pool and how much they're growing. Okay, makes sense. Next slide. So the API that the pool has to implement are these 3 methods. The first one, get pool info. This is what is called from either the GUI or the CLI. When the user wants to join a new pool, the GUI would call this endpoint and get all this information about the pool and display it to the user. So the user can see what are the settings, what is the fee for this pool, what is the payout interval, and things like that. And then the second API call is to post partials. And this is how you submit the proofs of space from the farmer to the pool. And it's interesting to note that there is no registration here. There is no sign up. The farmer can just start sending partials as soon as they want. They do need to have a singleton on the blockchain though. So before sending the first partial, they need to create their singleton, which I believe we call plot NFT for their user-facing interfaces. But after the farmer creates their singleton, they can just instantly start sending partials to the pool. And then there's a third one, which is get login, which is used for user interfaces. So if the farmer wants to log into the website of the pool, this is a common use case in proof of work cryptocurrencies. You can see your rewards, you can change settings, etc. We also have a protocol for this, but this is optional. It's not necessary for pooling. You can only implementing the first 2, you can successfully do pooling, because there is no real reason to log in at a website, because in the Chia GUI or in the CLI, you'll be able to change pools, set the reward address, and see your status in that pool. So the get login is optional, and it's not finalized yet. We're discussing how to do that. Okay, yeah. Okay, so let's show a quick demo about how some of this stuff works. Can I get shared permissions? Let's see, desktop. Do you all see this?
Starting. There we go.
Okay, so I have two computers here. They're both on testnet 7. So the white GUI and the black GUI. So we have this new thing called the pool tab here. And here the user can see all the pools that they have joined. So each one basically represents a singleton. So you can see the name of the pool. That's returned by the get pool info API call. You can see the URL of the pool, how much you've won so far, the current difficulty that pool has assigned to you for that singleton, and points balance and points balance since start. I'll explain what points are in a second. So here you can see I have two singletons. This one has difficulty 10. This one has difficulty a lot more. And the reason why is that this one might only have like a few plots assigned to it. So its difficulty is really low. And this one has a lot of plots assigned to it. So the pool is kind of regulating that, and the pool is increasing the difficulty for this one. So the way it will work is the user will click on add a plot NFT when they want to create one. And you can either do self-pooling, in which you set the target address of the singleton to yourself, to one of your own addresses. So you have to claim your own rewards, and they will go directly to you, the 1.75. There's not much purpose in doing this, but it's an option for people. And then we have connect to pool. So the user would specify the URL. So let's do 45 port 80. So as I typed this, the GUI did a get pool info, and then got all the data from my local pool, which is running on this computer. And it sees the settings, right? It's important for the user to check this because they don't want to get scammed by that pool, right? If there's some malicious information here, the user should know about it. So once the user have verified everything, they click create, and that will get created in the background. The thing is, it has to confirm on the blockchain first. So we do need to add some stuff here, but basically there's a pending transaction that is waiting to get confirmed on the blockchain. So an important thing is that, let me explain the points really quick. So what is a point? So if we take a partial that has difficulty 10 and a partial that has difficulty 1,000, the one with 1,000 is obviously more important and worth more, right? Because it's more difficult to create that proof. So when the user is farming and submits a partial of a certain difficulty, they are awarded points in the pool database for the difficulty that they farm. So if you farm, if you create a proof with difficulty 10, the pool will give you 10 points. If you create a proof with difficulty 1,000, the pool will give you 1,000 points. So it doesn't really matter what difficulty you set because it's proportional, right? The higher the difficulty, the lower the chances of actually finding it. So the pool can kind of keep track of the points of all the users, regardless of what difficulty each user has. And also the user can see their points going up, and they can see how many points they found since they started the UI. And we're going to add more metrics like like how many points they earned in 24 hours, etc. Also, we want to add things like how many plots are in the singleton, etc. So there's some stuff missing here. But let me show you this RPC. There's this RPC called get pool state. And this returns basically all the points that the pool acknowledged in the last 24 hours. Okay, here. All the errors the pool gave you in the 24 hours, configuration for the pool, and basically a lot of information regarding points. So anyone doing any GUIs can also use this RPC to get all information about the pooling singleton and how many points the farmer found, etc. Okay, so as you can see, this got created in the blockchain. And yeah, so once it's created, then you can also create plots. So let's talk about that really quick. So how do you create a plot for that pool, for that singleton? So you add a plot.
Please don't plot K25s at home.
Yeah, K25s, they're not good for winning.
But for development.
Yeah. So now there's this extra step here in plotting, which is join a pool. And all the singletons you've created will show up here. So if you select none, that's going to farm in the normal way that we know up until now. But now you can select a reference pool, or you can see all your singletons here. And when you create them, that's going to use the new. There's a new command line argument for create plots, which is -c. Let me show that in the command line really quick. So here you can see this command Chia plots create. Okay, it's going. Let me zoom. It's going very fast. Here you can see Chia plots create, and I pass in this new argument -c. That is what is the pay to singleton puzzle hash that we talked about earlier, right? So basically each one of your singletons has a different pay to contract puzzle hash, and you specify it using -c when you're plotting. That's the same thing that I did in the GUI, but in the GUI, I just selected it from the dropdown. So I believe it's not here yet, that address, but we will add it here so you can just copy and paste it as well. Another thing to note is that you can also access these things from the command line. So you can do like Chia plot NFT. Let me zoom in a little bit because it's kind of small. So there's this new command line program called Chia plot NFT, and right now it's only created show, but then it will support pool switching very soon. So you can do Chia plot NFT show. And each one of your wallets has different plot NFTs because, sorry, each one of your keys can have different plot NFTs because they're tied to a key, right? Because it's a blockchain thing. So for example, here I have plot NFT. It says farming to a pool. This is the pool URL. This is the pay to singleton contract address or the pool contract address. So this is what I would copy, and that's what I would paste when creating a plot as a user. You can also do Chia plot NFT create. This is how you create a singleton or a plot NFT. It's the same thing. You say u 10.0.0.45. Specify the key that you want to create it to, and now it tells me we'll create a plot NFT and join this pool, and it shows me all the information, and then I can confirm yes or no. Do I want to create this plot NFT? And that's the same thing that I showed in the GUI for creating a singleton or a plot NFT, but you can do it in the command line too. Finally, the other thing I want to show is on the right side, I have the pool server running. So as you can see, this is returning points balance. So this means that a partial was submitted by the farmer. right? So it's returning the points balance. Every time the farmer submits a partial, the pool will submit back the points and the difficulty. And here you can see an error. So did not find signage point or end of slot. So sometimes when a signage point gets reverted for the blockchain from the blockchain, then that signage point is no longer valid, right? If there's a reorg in the blockchain and certain signage points are no longer there, we don't want to award farmers for that signage point anymore. So we basically will not give them points for a signage point that doesn't exist on the blockchain. Another thing it's trying to do here is it's trying to create a payment and distribute funds. It doesn't have any funds, so it can't actually create a payment. But there's a loop in the code for the pool, which basically says every day or every week, check how many rewards I've won and distribute to all the pool members. There's another matter which is about fees. As more pools start making payments to users, the fees might increase in the blockchain. So we also have to be aware of that and handle that. Anyways, that's the main demo for now. Some of the things that are missing from this demo are pool switching, which we're working on, but it's not ready yet. And yeah, paying out the rewards to the users. But that's basically it for the demo.
So a couple questions that have stacked up. Can I join two different pools with the same plots?
No, your plots are tied to a singleton, and the singleton can only be on one pool at one time.
Can pools ban users?
The pool can ban a user, yes, because it's the singleton ID or the launcher ID. It's encoded into the plot. So the pool can ban users if it wants.
Let's see.
It's not really, well, the pool can't stop someone from pointing at the pool, but the pool could not give them the rewards
Right.
if
they do that.
At the end of the day, the pool controls the rewards.
That's right. So in fact, one of the questions was, can a pool do a rug pull? Because someone was thinking that maybe we're keeping them from doing that. And the answer to that is?
The answer to that is, if you're getting paid, then it's fine. But they can do a rug pull for the payout interval, right? If the payout interval is 3 days, the pool can accumulate rewards for 3 days and then leave, right? And then never pay people. But that's what reputation is. That's why reputation is important, right? If the pool is never paying users, that's not a pool you want to join. You want to join a pool that is always paying out rewards with low fees.
And you can switch.
Right, you can always switch. So as soon as you realize that they haven't paid out in 3 days, then, or whatever the interval is, then you're like, okay, this pool is a scam. Let's go. So they can never steal user funds. They can only temporarily not pay out, if that makes sense.
Okay. How do end users get the singleton? We've talked about that before. I want to make sure we've mentioned that.
End users create the singleton using the GUI that I explained by clicking on Pools tab and adding a plot NFT. That's how they create a singleton.
I think the question was for those of them that do not have any mojos or any Chia.
Oh yeah, they can get mojos using the faucet, faucet.chia.net, I believe, or they can ask to a friend to give them a few mojos.
When you set a limit of proofs per user, are you technically putting a cap on farm size per user?
No, proofs per user are independent of farm size. If you have 100 petabytes, you just set the difficulty really high so that you still have the same number of proofs per day as someone with like 1 terabyte, right? It's just a matter of increasing the difficulty for each user proportional to their space.
Let's see. How can a pool identify the winner?
The pool can look at the pay to singleton puzzle. So it basically searches the blockchain for any money in this address. And if there's any money in this address, it knows that it's one of their users. So then it creates a spend for the singleton and that address.
When users submit partials, they kind of alert the pool to the existence of their thing.
How should you implement login for people who use multiple singletons but the same pool? Should they log in for each plot group separately?
Yeah, the login protocol as of now, it's per singleton. So you can't do a user-wide account for multiple singletons. I mean, the pool can add something to support that, but is not supported by default in the protocol.
This is a first version. There's there's stuff to be added.
Let's see. Can the 1.7525 split be changed?
No, that's in the source code and consensus rules, and that's there forever.
Yeah, the reason for that one is if there is a pool that's larger than that split, which there is right now, hopefully won't be in the future, then in principle, that pool, if they were making all the blocks themselves, which we're also not doing, could profitably attack other pools by joining other pools, collecting partials, and throwing out actual blocks that they collected, and just collecting their partials. If other pools just like completely untrustedly allowed you to do that, then it would be profitable for the pool in question, because even though the benefits they get are distributed in terms of reducing the work difficulty, are distributed across everyone evenly, there'd be a high enough proportion of everything that they would be net positive on that. So it's really bad policy to not have a split there. So we coded in that split. Also, the farmer gets all the transaction fees. One part of what's going on here is we really want farmers to be making blocks, not pools to be making blocks, because that's another safeguard against bad pool behavior. And if the farmer's making the blocks, it doesn't make sense for transaction fees to be going to the pool, because there are pretty straightforward kind of under the table ways in which people could pay farmers transaction fees that wouldn't exactly show up, because they'd be based on these anyone can spend transactions. And that's a bunch of chicanery we don't want to have. So we're just kind of skipping to the end and making it so that the farmers directly get the transaction fees.
Also, it's worth mentioning this not going to be 0.25 forever. It's going to have, but the proportion will always stay the same as far as farmers versus pool rewards.
And by the way, Bram's answer there is really important for those of you concerned about any one pool being very large. Unlike proof of work, our pooling protocol does not have the pool signing the actual blocks. And that removes a tremendous attack vector and basically keeps the decentralization quite high, actually. How can pools set minimum withdrawal limits? Can it change depending on the transaction fees of the network?
Totally up to the pool.
I believe we've answered this before. I want to do it one more time. Is the relation between difficulty and chance to find a proof linear? If not, would we need to adjust an algorithm to adjust point rewards?
Completely linear. The speed of Time Lords is also thrown in there, but for the most part, you assume Time Lord speed is kind of constant.
So, Bram, I'm going to ask you a couple questions just because we hear it everywhere all the time. Are we going to change the reward schedule? Can we ban a pool? Is this really decentralized?
No. Yes. The reward schedule is not changing. We don't do hard forks around here. We launch the network, and we're going with launching the network. Everything that we're releasing right now is layer 2 stuff. This isn't even a soft fork. We're changing nothing. Like, in principle, y'all in the community could have built all this, but we so far have all the expertise. We're trying to change that, but we're not. We just don't do forks if we can at all avoid it. We never do hard forks. We don't anticipate doing any soft forks for a good long time. This is all this is all layer 2 stuff. So no, we're not changing the reward schedule. That would be very, very bad. That would be us just acting as dictators of the network, not it being a decentralized network. And I mean, maybe we have enough of the software today that we could get away with that, but that's no DAO bailouts going on around here. What was the order? Oh, can we ban a pool? No, we don't control the network. This is censorship resistant. This is not under our control. What was the third question?
Oh, it was just, are we decentralized? I was kidding.
Yes, yeah, we're very decentralized.
Yep.
Aiming to be more decentralized in the future as things go on. In particular, we want to make sure that that there's a healthy ecosystem of multiple competing pools, none of which are particularly large.
I just want to add one thing. The support for the smart contract address, as far as the plots go, that's been in there since mainnet launch. So we haven't changed anything, like Bram said, we haven't changed anything to support this as far as the chain goes.
Yeah, this was all according to plan. It's just it wound up having to be on a very accelerated schedule. We, before pushing the release out with the consensus algorithm we have, we cranked up the number of reward events per day to basically as much as we dared without there being some serious potential like orphaning problems in the protocol. So there are almost 5,000 reward events per day that happen, which means that if you're 1/5,000th of the total net space, that you would get about 1 reward event per day. So if you know that would mean that if the net space was like 5 exabytes and you were 1 petabyte, you'd be getting about 1 reward event per day. And now we've blown way through that, so even a petabyte is getting a little dodgy. So the theory was, you know, if you're getting like at least 1 reward event per day, you're good. It's a little noisy, but it's like in the course of a month, maybe you get 20 rewards, maybe you get 40 rewards. You're getting pretty consistent rewards. Our initial coin price was higher than we expected, which has resulted in my thesis of people are going to be farming with all kinds of stuff has gotten validated a lot faster than expected. So the need for a pooling protocol has been a lot more than expected. So we've been really trying to get this out as quickly as we possibly can. We've only had real coin price for like a month. And the team's
Not
been
even
really,
a month.
Yeah. So the team's been doing a great job really cranking on this, but we're we're trying to do it right and fast, and it's a real struggle.
Just a reminder to everybody asking questions, this is for pool operators, not for end users. All of you want all your end user questions answered. Not today. Can anybody start a pool?
Yes.
But there are real issues running a pool. For those of you contemplating it and have not done it before, especially in the United States, you may need individual state licensing as a money transmitter. You'll have to issue W-9s to each of your pool participants. You probably have to KYC AML them. This is a non-trivial undertaking, and you're taking on financial responsibility for a large group of people. You will also be a target of every hacker and cracker online trying to steal your pool funds to take to their wallet. So I caution anyone that running a pool is not an easy thing. There are some questions about our trademark rules, and people are saying, well, some pools are using Chia in their name. And the answer is you can use Chia in your name. We prefer you not. And you definitely cannot use Chia as the first word. So you can't say the Chia pool or Chia pool. You can say a Chia pool. Someone's done that. That's skating up to the line, but please don't. What we're trying to do is make sure that no one believes that there is an official sanctioned pool. There will be no official sanctioned pool.
Yeah, we really want there to be a healthy ecosystem of pools. And as part of that, we're not running one ourselves.
Saw a question asking if there was going to be a GUI of some sort for pool managers that wasn't demoed today.
No, there's no GUI for pool operators. There's just a server implementation. It's called pool-reference, and it's on GitHub.
As to whether there will be, I'm sure something will be written in the future.
As with all things, used with caution.
Yeah. Bramer Mariano, can you walk through again why this doesn't have block withholding attacks?
What?
The idea being that if you want it, you wouldn't give it to the pool.
Oh, that attack. Sorry, there's a. When you say block withholding attacks, I'm thinking grinding attacks on consensus. It's because of that split where a bunch of the funds go to the farmer that you would, if the split was literally 0, then it just wouldn't cost you anything to mess with the pool by joining it and just burning stuff. But with the split, being the way it is, unless you're like a truly massive pool, you don't really benefit from attacking other pools in that way. You're disincentivized from doing so.
And also would like to point out that you can't redirect rewards. If you win a block, those block rewards are going to that singleton. There's no way to change where they go. They go to the singleton, and that singleton is tied to that pool for the time being. So there's no way to steal from the pool in that sense. You can't change where the rewards go when you win.
Yeah. There's a lead time you have to follow for exiting. So you can't go, oh, I want a block reward. I'm just going to keep it for myself. I'm going to leave the pool instantly and claim this block reward for myself. You can't do that. The pool has time to claim it.
Which ID is the main one for points aggregation? Launcher ID or P2 singleton?
The P2 singleton is derived from the launcher deterministically, so they're both unique. But we've been using launcher ID as the main ID for everything.
There might be other pay to singleton things that are done. Like we've internally discussed making it so that so there's a pay to singleton that has like a trapdoor in it, so that if like a pool just kind of goes offline or just stops functioning, that the actual farmers to it can go claim those rewards for themselves if the pool just takes forever to do the claiming. And that would be a different pay to singleton ID, because that's a different format. But there's nothing stopping pools and wallets from supporting more new formats like that in the future. We're just trying really, really hard to make sure that our singleton format supports all these things going forward, because people are going to be making singletons now and you want them to keep working in the future.
I know we've answered this before, but let's do it again. How can a pool and other users be confident that a user isn't faking their space?
Using partials. One thing to note, it's a really good idea for pools to get pretty pissy if users are sending in partials late, even if it's just like a few minutes late, mostly because it's pretty easy for there to be users who have like really, really jank setups where they're making proofs of space but so slow that they won't be able to successfully make a real block when they do. So it kind of behooves pools to only give credit if those things are made reasonably fast, so that in the event of them actually making a block, the block actually gets made.
Mariano, where's farmer points stored? Is it on the blockchain or with the pool operator?
This is in the pool operator's code. The point stuff is completely separate.
Yeah, so the amount of trust that's going on here is that the user is trusting that the pool will give them fair returns for their partials kind of in the near term. The user can audit the amount of returns they're actually getting from the pool and see if they're getting stiffed. And if they want to leave the pool, they can go ahead and do that and only miss out on a transition period's worth of stuff. And the pool is really not actually trusting the user that much. The tool is trusting the user to actually make blocks if we get them, which they're of course very, very strongly incented to do, because that's a lot of money if you do succeed in making a block. But the pool doesn't have to trust the user to not just claim the rewards for themselves. The pool can go ahead and claim the rewards on their own. And worst case for the user, they get stiffed a little bit by the pool, so they leave the pool and start farming or go to another pool, but the pool can't stop them from doing that.
Will we have a reference on GitHub for implementing pools?
Yes. We already do.
We do, right.
There's instructions on how to run your own pool on testnet. It's not, it's still a little rough around the edges, but you can at least start preparing your pool and creating plots for it on testnet and practicing, how you would run your pool on mainnet. So we'll talk about it a little bit later.
Yeah, one thing we should re-emphasize. Plots that you make on testnet with the pooling protocol won't work on mainnet ever. They will not. They are pointing at a singleton that does not exist on mainnet. So be very, very aware of that. Do not make your real pools on testnet here.
Yeah, the way
your real plots on testnet.
The way to think about that is if you used XCH to create your singleton, it's a real mainnet singleton. If you use TXCH, it is locked to testnet.
We'll cover that more in details in the subsequent slides.
Let's go back to that.
Yeah.
Okay. I know you guys have a whole bunch of more questions. Please start putting them in the pools channel. Devs are going to actively start looking at that again since they can have a little bit time now since a good chunk of the pool reference code is done. And I will always be the catch-all of capturing questions that haven't been answered. Okay, so is my screen shared now?
It is.
Okay, awesome. So a couple things. One, you guys are all pool operators and devs, so you understand this, but we want to make it very clear. We will no longer be issuing specific target dates. We've been burned. We're not going to do it again. We try to give more transparency about goals of what we're trying to achieve, but dev is hard, right? So instead, we're going to have 3 stages, which we'll announce each stage very clearly, and we will make sure everybody understands what the stages are. First stage that we're coming up on, which we don't have a date yet, but we're working very fast to getting there, is the testnet launch. The whole idea here is we get iterative releases to allow Chia devs, the community, the pool operators to find and fix bugs in the reference code and their pooling software, okay? It's the place where we try to get it all working. When we feel most of the critical bugs are done, we're going to announce we're going to go into pool self-validation stage on testnet, which is basically saying we're going to let our pool reference code bake for a few days. Make sure there's no last minute bugs, make sure everything's working. Pool operators can also do the same if they're ready. But basically, when we feel it's baked good enough, we will launch to mainnet, okay? And everybody can use it. Now, the key question everybody's gonna ask, because it's nonstop, is if I have the skills to use testnet code, can I plot portable plots for mainnet? And here's a whole 2 slides to explain why that's a bad idea, okay? So 1, as mentioned earlier, portable plots created using testnet singletons using TXCH will be tied forever to testnet. You'll never be able to use that mainnet. So even if you try this, be very careful how you try it because you might have just wasted a whole bunch of time. Second, if you do portable plots using a mainnet singleton using testnet builds, remember, we first launched this right away so we can test it. We might have missed a few things. There might be bugs. Any bugs we fix will invalidate or at least limit or have broken functionality for that singleton. It kind of might work. You might be able to farm with it, but we might have a bug where you can't claim the pooling rewards. So you're back to square 0, okay? So our recommendation is if you have the skills to do it, wait till at least we get through pool self-validation stage. When we say, hey, we think we're pretty good, then your viability for using testnet code to plot for mainnet might increase a lot, okay? But if you do it beforehand, you're just taking all the risks with probably very little reward in that, okay? Now, if you want to guarantee that every plot you created for portal plots work, wait for mainnet. Otherwise, there might be something janky and we can't fix it for you, okay? So keep that in mind. So another slide to reinforce this. On testnet launch, the target audience is for Chia dev, community devs, and pool operators. Okay. Any testnet plots you create with TXCH won't work on mainnet for sure. We're guessing is a less than 10% chance that if you use the testnet initial launch code to create mainnet portable plots, you probably have maybe 10% chance or less for it to actually work in mainnet. Okay. We're not saying it's zero, but it's pretty close to zero. Okay. Once we get to pool self-validation stage, we invite those cutting edge community members who really like to take risks to go ahead and try to use testnet code, not only on testnet, but if they want to try plotting on mainnet, go ahead. But we can't guarantee it, but we think probably around 75% chance it'll work fine, okay, by that stage. And obviously, once we launch mainnet, we will for sure make sure it's viable 100%. We won't launch it otherwise, okay? So that's that. So we already did the technical Q&A, and we'll let Bram.
Will always work.
This is very true. So we already done the technical Q&A, and we're already running a little late. So I want to add one last thing. As soon as Chia Dev validates the pool reference code, has no critical bugs, and works properly end-to-end for 3 days, we're launching in mainnet afterwards. Now, is it going to be exactly after 3 days? Well, there's a build process and all the other stuff. But basically what we're saying is we're going to bake it. Once we say we think we're going into pool validation stage, we're baking it for 3 days. If we find a critical bug, the clock resets. And then we fix that bug, and then we try again for 3 days. Once we feel 3 days is good, we're launching the sucker. That's how you'll know when it's ready to launch. Okay? Please, no more when pools dates. When we get to this stage, it's probably going to be within 3 days unless we sign something critical. Okay? So that's it for the presentation. And thank you very much for everybody joining. This will be up on YouTube. We will probably do follow-up Zoom call if we think it's necessary. But right now, we're going to take most questions on Keybase Pools channel. So, and anybody want to wrap up? Gene, Bram?
Thank you for being patient. We've been live over a month, and we'll have this to you shortly. It is one of the cooler implementations of Chia Lisp so far.
Yeah, we've really been. Oh.
You're here. You're still here.
Oh yeah, sorry. We've really been dogfooding Chia Lisp with this, and so if you dig into how it's implemented, it really involves some really interesting and very powerful techniques. So not only is this useful just as pooling, but as like our first beachhead dog-fooded example of Chia Lisp development as well.
Okay, everybody. Thank you very much. Again, Keybase Pools channel, primarily targeted at pool operators. Everybody who asks when pool is generally not going to get an answer. Sorry. Soon is the answer. That's the answer you're going to have to live with. We look forward to everybody designing and building their pools. Also, though, one last thing, caveat emptor, pools can still steal from you. You need to make sure that you trust the pool you're going into, and you keep an eye on that pool to make sure it's paying you out appropriately. Okay, thanks everybody, and we'll be back here later on a subsequent Zoom. We'll probably do an AMA here shortly for user questions, not for pool operators. Thanks again, everybody. Bye-bye.